Tobela Dumela. In this video, we are basically going to be looking at domain and the range of different functions, specifically hyperbolic and exponential. I think we would look at the domain and range of exponential functions in the next video. So whenever they talk about domain and range, I have realized that some tend to have a problem. That's probably why you're watching the video. Let's look at it like this. We have domain, we have range. D and R, as you can see, the D and R, D comes before R, basically. So this is just a way in which you can remember which one is for the X values, which one is for the Y values. So when they talk about the domain, they're talking about all the X values for which the graph is valid. And when they talk about the range, they're talking about all the Y values of the function for which the function is valid. Basically, that is all the Y values where the graph exists, or all the X values where the graph exists. So let's look at let's start with the domain so that it makes sense what we are saying here. So starting with the domain, we are saying this is the values of X for which the graph is it's valid. As you know, we have a Cartesian plane for graph F, and this is the X axis and we have the Y axis, like that. So when we are looking for the domain of F, okay, we are looking at all the X values for which the graph is valid. So this is how you can go about doing that, or making sure that you understand. Moving from left to right, you can see that all the X values, this graph is touching them, except where X is equals to 1. You can't find the graph, okay? But all the X values, you realize that the graph is valid for those. So when you are required to determine the domain for this graph, it's basically X is an element of real numbers. That's all the X values, except that X is not equals to 1. So you're just excluding 1. This is how you can write the domain for this function, okay? And also the other way to write the same thing is to say that X is an element of from negative infinity all the way up to 1, and then you're just trying to exclude 1 or union okay, from 1 all the way to positive infinity. Because you are using circular brackets here, this shows that you are not including 1. So basically these are just two different ways of writing the same thing, but they all say the same thing. So you're saying from negative infinity to 1, union from 1 all the way to positive infinity. That's basically just the same way. Or the third way of saying the same thing, you can say that X is less than 1 or X is greater than 1. Okay, I think the third one is much more easier, but they are all easier if you just try to understand what they are saying. So the third one is saying X is less than 1 or X is greater than 1. You will find the graph where X is greater than 1 or X is less than 1. The graph does exist, as you can see. And now in terms of the range, okay, the spelling for range is not what I just wrote, okay, butchering it for the second time. Okay, now that is the right spelling. In terms of the range, we are basically just saying all the Y values for which the graph is valid. Which Y values? You can just start from the negative infinity of the Y values. As you can see, this graph exists for all these values. Until you get to 2, it's not there. There's no graph there. And then after 2, you'll see the graph is there. Because these lines that I'm drawing, these horizontal lines, they are touching the graph at some point. That's to show that the graph is there for all those Y values. Okay, so you can say Y is an element of real numbers, but Y is not equals to positive 2. And you can maybe write it as y is an element of from negative infinity all the way to positive 2 union from positive 2 all the way to positive infinity. Or the third way to write it is to say y is less than 2 or y is greater than 2. For y is less than 2, the graph exists, and for y is less than 2, the graph exists. That's basically what the last one is saying. I hope that is 3 different ways of writing the same thing which you happen to understand. Let's try with G, a graph G, which is a hyperbolic, not exponential, it's parabolic actually. Quadratic or parabolic, quadratic or parabolic, yes. So let's try to see how we are going to go about determining the domain as well as the range. For the domain, we are looking at all the x values for which the graph exists. As you can see, from left all the way to the right, this graph exists. These arrows, they are showing you that all the way going there, the graph exists, and all the way going there, the graph exists. So for the domain of this graph G, it's just that x is an element of real numbers. We are basically saying this graph exists for all x values. There's nothing that we need to exclude here. Or we can write it as x is an element of negative infinity all the way to positive infinity. As you can see, these are just the 2 different ways of writing the same thing. Okay, and in terms of the range, for the same, I keep butchering the spelling of range for some reason which I don't know. Okay, let's stop butchering the spelling. And in terms of the range, we are looking at the y values for which the graph exists. You can see maybe from, let's start from the bottom going up, it's not there, the graph's not there until you get to -6. That's where the graph starts existing until all the way to positive infinity. So basically the graph exists from -6 all the way to positive infinity. So what we can say is that y is greater or equals to -6. That is the range. This is the range where the graph exists. Or we can say y is an element of, we're going to use square brackets to show that we are including -6 all the way to positive infinity. Okay, I hope you understand. That's just how you would write it. And if maybe we had a different shape, which is now, it's basically the same shape but it's facing downwards, how you get the domain is that domain is for all the x values for which the graph exists. So as you can see, we will do again what we did in the previous question rather. So you can see from left to right, it exists, this graph, all the way from -x until positive x's. It does exist. So x is an element of real numbers. That is the domain. Okay, or we can say x is an element of negative infinity all the way to positive infinity. These are just 2 different ways of writing the same thing. You don't have to write both, you just have to write one. And in terms of the range, whoever gave me the wrong spelling of range, hi, it's fine. In terms of the range, we are going to say this graph exists from 8 downwards. This is where the graph exists, from +8 all the way downwards. As you can see, above 8 there's no graph there. So the range, you just have to indicate that the graph exists from y is less or equals to 8. That is the way you can write the range. Or alternatively, you can write it as y is an element of, you're going to use square brackets to show that you are saying from 8, including 8, and then all the way to negative infinity, not positive but negative infinity, because you are going downwards from +8 downwards. Okay, yeah, this is just 2 different ways of writing the same thing. I hope this video gives you an idea of how you can identify the range as well as the domain and write them or represent them. I will see you in the next video. Please do like and subscribe to the channel, as well as what is it, you can also comment. Yes, see you in the next video.